Welcome to homework.
Okay, so what we need to know is if E naught cell is positive or negative. Okay, so if it is positive, then it will be able to oxidize, and if it is not, then it will not be able to oxidize. And how do we calculate this E naught cell? So this E naught cell is actually equal to E cathode minus E anode. So we'll start with the first part. So in the first part, you have anode, which is hydrogen. So you have 2H positive with 2 electrons forming H2. Okay, and we know that this has an E naught of 0.0 volt. And then you have a cathode, which is copper, forming copper 2 positive plus 2 electrons, and this has a standard potential of negative 0.34 volts. So now E E cell will be equal to E cathode minus E anode, which is equal to minus 0.34 volts, right? So this means H positive will not oxidize copper to positive. Okay, moving on to the next one. So we have to see if iron 3 positive will oxidize I negative to I2. So again we will start with anode. So at anode I have the negative ion. So I have 2I negative forming I2 plus 2 electrons, and this value is equal to minus 0.54 volts. And at cathode I have iron 3 positive with 3 electrons, with 1 electron forming Fe2 positive, and this E naught is equal to 0.77 volts. So E naught cell will be equal to cathode minus anode. So this gives me a value of 0.23 volts. This is positive, right? So since E naught cell is positive, Fe3 positive will be able to oxidize I negative to I2. So this gives us B part. Now we move on to the C part, which is H2 reduce Ag positive to Ag. Now this is exactly the opposite, but the same concept. So first we'll do anode. So this is, we know we have H2, this is nothing, plus 2 electrons, right? So this value is equal to 0.0 volts. And then I have a cathode, which is my silver ion, gaining 1 electron to form silver metal, and this is equal to 0.8 volts. Okay, so my E naught cell is equal to 0.8 volts minus 0.0 volt, which is equal to 0.8 volts, which is positive. So H2 will be able to reduce Ag positive to Ag metal. Okay, so this is all that we need to know.